All right, now it's time for some review for the chapter 7. So I got page 379, number 11, 17, 29, 38, and 69. The last problem we're just going to do parts of it. If I can give you guys some little bit of motivation on this thing, you want to just plug and chug on these, and you want to keep going until it works out. Sometimes you pick the wrong U when you do a U substitution and it doesn't work out, so what you want to do is you want to cross out the work and start over again. So on this paper, I may make a mistake. I'm going to try and go right to the correct answer. But if you don't get what I get right away, that's okay. That's the whole point, is that we're trying to learn how to do this thing. So we're going to start off with number 11, and number 11, the directions say evaluate the integral. We have the integral of cosine of x over 2 minus sine of x. I think we did an example like this in the class. And so I'm looking at that and I say, I know that my derivative of my sine is cosine. I also know that the derivative of my cosine is negative sine, but this 2 makes it a little bit harder. You have to have that derivative have that 2 in it too, and the derivative of cosine doesn't have a 2. So that is a clue to me that I'm going to make u equal to 2 minus sine of x. Then when I go to take my derivative, I get du equals, the derivative of 2 is 0. The derivative of sine is cosine, and then we have a negative, so we get negative cosine of x dx. We solve for dx, and we get dx equals du divided by negative cosine of x. Alright, so now we're going to take this, we're going to plug it into the integral. We got nothing over here is cosine, so we leave the cosine of x in there. 2 minus sine of x is u. Then our dx is du divided by negative cosine of x. So that helps us. The cosines cancel out. We have this negative. We can pull the negative right out in front. We have the negative integral of du divided by u. And because we've been doing this so many times, we know that's the natural log of the absolute value of u plus c. Make sure to not forget to plug that u back in, and we get the negative natural log of 2 minus sine of x plus c. So it works out pretty good. If you used u as your cosine of x and it didn't work out, remember, cross out the work and just keep going again. So 17 gets a little bit tricky. You got to realize there's going to be a lot of natural logs in there, and you got to understand what's going on with the natural logs. So if I looked at this problem, I would say natural log of x, the derivative of natural log of x is 1 over x. And so if I looked at that, I would say, oh, my u is going to be natural log of x. Du equals 1 over x dx. Then dx equals x du. So now we go through, we take this, dx is x du divided by x. We don't have anything for x, but we do have u is the natural log of x, so we got u. Check this out. The x's cancel out, and now we have the integral of du over u. Now what you got to do is you just got to trust it. You got to trust your calculus. You got to trust that it's going to be right. You've done everything correct so far. The antiderivative of this is the natural log of u plus c, and in this the u is the natural log of x. A lot of people right here get freaked out and they go, oh, there's no way it could be that. But the actual answer is the natural log of the absolute value of the natural log of x, because that's what u is, plus c. When you do that, you got your answer. Alright, these ones, I like these ones. Multi-step problems. We're given the second derivative. We know that x is greater than 0. The derivative at 1 is 1, and y of 1 is 0. So right away I'm going to look at this and I say, oh, I got a x in the denominator, so I want to change that. D squared y over dx squared equals 2x minus x to the negative 2. Now when I take my integral, that's going to be easier to do the power rule on. So I got the integral of d squared y over dx squared is dy dx, which is equal to the x squared divided by 2, minus x, negative 2 plus 1 is negative 1. A lot of people make the mistake and they take that and they make that equal to negative 3. So make sure you don't do that. So this gets us x squared, then minus x becomes plus 1 over x plus c. Now we got to plug in our derivative into here because this is what dy dx is. we can't find the antiderivative of this c until we know exactly what c is. And the reason why is if it came out to be 0, the antiderivative of that is nothing. So you want to plug in 1, 1 into this equation, so we get 1 equals 1 squared plus 1 over 1 plus c. So 1 equals 1 plus 1 plus c. 1 equals 2 plus c, so c equals negative 1. So this dy dx is going to be x squared plus 1 over x minus 1. Alright, now take the antiderivative of both of these. This gets us y equals x cubed over 3 plus 1 over x. The antiderivative of 1 over x is natural log of x. It's going to come up, so be ready for it. And then the antiderivative of negative 1 is negative x plus c. Once again, we're going to plug in our x is 1 and our y is 0. So we got 0 equals 1/3 plus the natural log of 1 minus 1 plus c. So 0 equals 1/3. Natural log of 1 is 0 minus 1 plus c. Doing some quick algebra, we get c equals 1/3 minus 1 is negative 2/3, so c equals 2/3. Okay, don't fall into the trap of thinking, oh, I did a great job and I'm done. Remember, we want to find out what this y is. So you got y equals x cubed over 3 plus the natural log of the absolute value of x minus x, and then the c is 2/3, so we got plus 2/3. That's our answer to number 29. Alright, moving on to 38. Slope fields. Make sure you get these slope fields correct. Look for patterns, know what you're doing. I right away look at dy dx equals 1 minus y. If y is 1, then my slope is 0. So I go to all my where my y's are 1 and I put in my 0 slopes. Okay? Then everything in this row, y equals 2. So dy dx when y equals 2 is 1 minus 2, which is negative 1. So we draw in our negative 1, negative 1, negative 1. Plug in right here, y is 0, so we get dy dx when y is 0, and that gets us 1 minus 0, so it gets us 1. So positive 1, positive 1, positive 1. And then dy dx when y equals negative 1 gives us 1 minus negative 1, which is 2. So positive 2, much steeper, much steeper, much steeper. There's full credit right there. Right? All right. Now we got dv dt, number 69 says dv dt equals negative 2 times v plus 17. And it says v of 0 equals negative 47. So the actual equation says let v of t be the velocity in feet per second of a skydiver at time t seconds, t is greater than or equal to 0. After her parachute opens, her velocity satisfies the differential equation dv dt equals negative 2 times v plus 17 with initial condition v of 0, negative 47. So this is the change in the velocity. So dv dt, if you wanted to make this easier, dv dt is going to be our acceleration. Alright, so we're going to split these up into known values. So dv, or separation of variables, dv gets this v plus 17 on the bottom. We divide both sides by v plus 17. And the dt is just going to be multiplied to the other side, so we get negative 2 dt. Going through this, we get, this one is a u over v plus 17. The derivative of v plus 17 is 1. So this just gets us the natural log of v plus 17 equals negative 2t plus c. Now we want to rewrite this in exponential form, so we get v plus 17 equals e to the negative 2t plus c. Okay, this plus c can come out in front because we've done this so many times. This is just the, so if we have x to the a times x to the b, that would be x to the a plus b. So what we're doing is we're going, instead of going from x to the a times x to the b, we're going from x to the a plus b, and we're splitting it up, x right here, x to the a plus b, and we're going to split it up into the x e to the negative 2t times e to the c. And then we know e to the c is just a constant, so this is v plus 17 equals c e to the negative 2t. Okay, then we get v of 0 equals negative 47. So when t is 0, the velocity is negative 47. We can, because we want to get this as a velocity function, we would say v equals c e to the negative 2t minus 17. We plug in 0 into here for that and negative 47 into the velocity. So negative 47 equals ce to the negative 2 times 0 minus 17. So e to the 0 is 1. We get negative 47 equals c minus 17. C equals negative 30. So then that gives us our velocity function. V of t is going to be negative 30 times e to the negative 2t minus 17. All right, so then B asks us to do, use a separator. Okay. Terminal velocity is defined as the limit as t approaches infinity of v of t. Find the terminal velocity of the skydiver to the nearest foot per second. So this is the answer to A. All B is saying is, who cares what terminal velocity is? All it says is, find the limit as t approaches infinity of negative 30 e to the negative 2t minus 17. So for me, it's easier if I rewrote this as negative 30 over e to the 2t minus 17. So if I plug in infinity into here, I plug in infinity into there, this negative 30 divided by infinity is going to get closer and closer to 0, so my terminal velocity is going to be negative 17. Okay, it is safe to land when her speed is 20 feet per second. At what time does she reach this speed? So this is a calculator problem. I'll set it up for you guys. All we do is we make our velocity 20 equals negative 30 e to the negative 2t minus 17. Add 17, we get 37 equals negative 30 e to the negative 2t. Divide by negative 30. That goes away. Take the natural log of both sides, and we get this should be a negative 20. So negative 20 minus 30. We add 17. This should give us a 3. Sorry about that. That's where the parachuter is going down, so the velocity, if there's safe speed, it will still be going down at 20. So this is going to be, add 17, we get 3, negative 3, so that gives us 1/10. So take the natural log of both sides, we get negative 2t equals the natural log of 1/10 divided by negative 2, and that'll give us our answer for our time. Alright guys, test is coming up. Make sure you guys study really hard. Look at the U substitutions, know all your integration formulas, and as always, if you have any questions, email me and I will be able to help you.